Hello everyone, this is Mr. Underkoffler, and today we're looking at part 2 of the guided notes called Working with Equations Like Their Balances. And so we've already done the first page, so now we are on the second page. And again, the directions are still the same as they were for numbers 1, 2, 3, and 4, and that is to work down on both sides of the equation. And so as I've talked about before, the equal sign is what separates the left side from the right side of the equation. And I am choosing something completely random to do to both sides of the equation. Like on number 13, I am multiplying by 12. And so our goal here today on these guided notes is just to work down on both sides. And we are allowed to do whatever I want on both sides of the equation because of the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality, which basically says you can do whatever you want to both sides of the equation as long as you do it to both sides. The same thing to both sides. So problem number 13, very first thing we should do is find that equal sign, bring it straight down. The right-hand side of the equation is pretty simple. I'm just taking 3 and I'm going to multiply it by 12. That's really simple. That's just going to give you 36. But the left-hand side, this is much more interesting. W over 6, a fraction, which technically means W being divided by 6. And then we're going to multiply that by 12. So how in the world do I do that? Well, let me tell you what's not going to happen. That 12 is not going to get multiplied to the 6. Why? Because the 6 is in the denominator of a fraction, and a whole number of 12 is not the same as 12 being in a denominator of a fraction. And so what I want to show you here is we're going to do a little bit of work off to the side of this piece of the problem. So perhaps you should draw a little bit of an arrow like I just did. And let's rewrite this. W over 6. And what am I multiplying it by? I'm multiplying it by 12. Now, since I'm multiplying a fraction times a whole number, I should convert that whole number to a fraction. It's a very simple rule with multiplication of fractions. You want to have a fraction times a fraction. So what could 12 be written as in fraction form? It can be written as 12 over 1 because 12 over 1 is like 12 divided by 1, which is equivalent to just 12. So this proves that we can write the whole number of 12 as 12 over 1. Now, multiplying fractions. I don't know if you remember how to do this from previous instruction. I know you had some multiplication of fractions in 6th grade math. You might have had some with me this year, depending which class you're in. But it's real simple. You're going to multiply the numerator times the numerator. W times 12. Not much you can do with that, but you could write it a little simpler. Call it 12W. Then you will multiply the denominator times the other denominator. 6 times 1, that would give you 6. So that's really simple multiplication. And look, this is proof that the 12 never got multiplied to the 6. There's your proof. Now, there's a little bit more we can do with this. Since the fraction bar means division, 12W over 6 is like 12W divided by 6. What do we know about 12 divided by 6? It would give me 2. And so this shows you that the left-hand side of the equal sign will end up simplifying to 2W. Make sure you have all of that written down. All right, let's do number 14 as well. First things first, find the equal sign, bring it straight down. The right-hand side of the problem is pretty simple. We just have -4 times -33. A negative times a negative is a positive. This would give you 132. You are technically allowed to use a calculator if you want to, although I bet a lot of you could have figured that out, without a calculator. The left-hand side where the fraction of h over 11 is located, this is going to be the trickier side, okay? We are multiplying this by -33. How do I do that? Once again, I would do the same type of side work that you saw me doing on problem number 13. So let's go a little bit here to the left. I'm drawing my arrow, not that you have to draw an arrow, but we're going to have what? H over 11, that's what we had, times, what am I multiplying it by? I'm multiplying it by negative 33. All right, let me get this out of the way. How do I multiply? Oh, so that negative 33 is the same as negative 33 over 1, because anything over 1 is the same as just the value of the numerator. So negative 33 over 1 is what negative 33 can be written as in fraction form. So from here, we are going to multiply the numerator times the other numerator. So h times negative 33. Not a lot I can do with that, but I could write it a little bit simpler as negative 33h. All right, put your fraction bar. Let's now multiply the denominator times the other denominator. 11 times 1 would give me simply 11. The fraction bar, as I've told you before, means to divide. So negative 33h over 11 is like saying negative 33h divided by 11. And negative 33 divided by 11 would be negative 3, and then the h obviously would stay, and that is how the left-hand side of this problem becomes negative 3h. All right, if you need to hear anything explained for a second time on 13 and 14, please take advantage of a pre-recorded video and rewind if you have to hear something explained again. At this moment, I would like for you to try 15 and 16 on your own. You can use 13 and 14 as a guide to assist you. So hit pause on the video, do 15 and 16 right now. All right, let's see how you did. Hopefully you already did 15 and 16 on your own. Number 15, first thing we do is we find the equal sign. The right-hand side is really simple. Negative 2 times 35, we're working straight down. That would give us negative 70. The left-hand side is much more interesting. We have the fraction of n over 7, and we are multiplying it by 35. So let's put a little side work over here. N over 7 times 35. 35 is the same as 35 over 1. Let's multiply numerator times numerator. N times 35, we can write as 35n. 7 times 1 for the denominator times the other denominator. 7 times 1 gives you 7. The fraction bar, as I've told you before, means division, so we can simplify this. 35n over 7 is like 35n divided by 7, and that would give you 5n. And that is working down on both sides for problem number 15. Problem number 16, we have 10 times 27 on the left-hand side. That's pretty simple. Multiplying by 10, you're just going to tag a 0 on the end of the 270, or sorry, on the end of the 27, which makes it 270. I got a little ahead of myself here. I should have said we should have started by bringing the equal sign straight down. Apologize, I'm struggling speaking today. Right-hand side, x over negative 3 times 27. So let's write that out. Let's do a little side work. Numerator times numerator. X times 27 is going to be 27. Why do I have n? That's a typo. That should be an x. So let me fix that. That should be 27x. My apologies here. And then that would be over negative 3, because negative 3 times 1 is negative 3. And then the fraction bar means to divide. So 27x divided by negative 3 would give me negative 9x. Positive divided by a negative is a negative. And that's how that works out. All right, the last part of the guided notes reviews something that we just did in the previous chapter. And that is, when do you use the distributive property? You might remember back when we simplified algebraic expressions, and back when there was a multiplier sitting outside of parentheses. Now, how do I know that 22 is a multiplier? Because there's nothing between the 22 and the parentheses. So that means 22 times the parentheses. And so what we learned is that you could take that multiplier and multiply it times both the x but also the 5. That's what you do when you have something being multiplied to an addition or subtraction problem, like we have here, addition in between. So 22 times x and then 22 times 5 would give us 22x plus 110. Now, why am I reviewing this with you? If your original equation has addition or subtraction, and if you are multiplying a number to both sides of the equation, then that means you're going to have a multiplier to an addition or subtraction problem. That is where you must use the distributive property. You must. There is no other way. That is when the distributive property must be used, when you have a number being multiplied to an addition or subtraction problem. And so take a look at number 17. What do we have? Addition. What am I doing? I am choosing to multiply by 22 on the left and right hand side of the equal sign. When you have 22 times an addition problem, x plus 5, then you must take the 22 not just times the 5, which would give me 110, but you must also take the 22 times the x. Why? Because this is the situation where the distributive property must be used, when you have a multiplier times to an addition problem. And that's why it becomes 22x plus 110. The 22 got multiplied to both the x and to the 5. That's the distributive property. Even though you did not see parentheses around the x plus 5, this is still the situation where the distributive property must be used. And then, of course, the right-hand side, negative 3 times 22, gives me negative 66. All right, let's do one of these together. Problem number 18. Find the equal sign. There it is. Boom, bring it straight down. Right-hand side is really simple. Negative 8 times 6, negative 48. Left-hand side, notice what we have, an addition problem. And what am I doing on both sides? Well, I'm multiplying by 6. This is where you must use the distributive property. 6 times y, but also 6 times the 11. 6 times y is 6y. Bring the addition symbol in between. 6 times 11 is 66. And that is how you would do an equation like number 18, y plus 11 equals negative 8, and you're multiplying by a number on both sides. Distributive property must be used on the left-hand side where there was the addition problem. All right, you will also see that there are a couple more problems here, 19 and 20. You're eventually going to do those on your own. Before you do, may I remind you that if there is subtraction, like on number 19, m minus 42, you should make it adding the opposite. Please do not forget that. Now, from here, I want to skip 19 and 20 for now. You're eventually going to do them. I want to talk about 20, 21, and 22. Follow along. There's a little sentence up here that you need to check out. The distributive property should also be used when the original equation has addition or subtraction and you are dividing by a number on both sides. Believe it or not, you're going to use the distributive property. And it's because of a rule you might have learned with fractions, that division is the same as multiplying by the reciprocal. Now, we're not going to do reciprocals right now, but that means every division problem has the ability to be rewritten as a multiplication problem using the reciprocal. And if you would use the distributive property when you're multiplying to an addition problem, like on number 20, there's an addition problem here on the left-hand side of the equal sign, then you also have to use the distributive property when you are dividing the addition problem by a number. So here's how it works. Take a look at number 20. The 18h and the 2 gets divided by the 3. 18h divided by 3 would give you 6h. 2 divided by 3, what's that going to give you? Well, I know you're allowed to use a calculator, and that could give you a repeating decimal, but let's work smarter, not harder. 2 divided by 3 is 2/3. That is so much easier to do than spending your time hitting 2 divided by 3 in your calculator and getting an ugly repeating decimal. No. Let's work smarter, not harder. 2 divided by 3 is 2/3. And then, of course, the right-hand side of the equal sign, 27 divided by 3, obviously will give you 9. And guys, this continues to happen. Take a look at number 21. We have an addition problem. And what are we doing? We're dividing it. So the 20x must be divided by 4, gives you 5x. The 36 also gets divided by 4, gives you 9. Problem number 22. Now, pencils in your hand. Something should happen on number 2 or 22's original problem. The subtraction should be made adding the opposite. Please remember to always do that. And again, the distributive property is going to happen with division. 7n divided by 10 gives you 7/10 n. Negative 30 divided by 10 gives you negative 3. Now, take a look at the right-hand side of the equal sign. 8 divided by 10 is 8/10, but they're both divisible by 2, aren't they? So that would reduce to 4/5. You might want to write that off to the side of your number 22, where this 4/5 came from. It's because 8 divided by 10 is 8/10. That becomes 4/5. Okay, I've now talked you through many examples. It is now time to go back and do number 19 and 20 on your own. Then try 23, 24, and then also number 25 on your own. So hit pause on the video, do those remaining problems on the second page on your own. Do them now. Okay, I hope you already did 19, 20, and then also number 23, 24, and 25. Let's see how you did. Pencils and erasers ready. Fix your errors if you make any errors. Number 19, did you find the equal sign? Bring it straight down. The equal sign should always be lined up. Did you already make the subtraction adding the opposite like when I was talking about it earlier? The negative 2 must get multiplied to the m and to the 42. So let's see if you did that. Negative 2 times m is negative 2m. Negative 2 times negative 42, a negative times a negative would give you a positive 84. 16 times negative 2 on the right-hand side of the equal sign would give you negative 32. Problem number 20. We have addition in between, and we are multiplying by a negative 12 on both sides. So the negative 12 must get multiplied to the negative 2v and to the 9. And then, of course, on the right-hand side, negative 12 gets multiplied to 5. Negative 12 times negative 2v is positive 24v. Negative 9 times 12, positive 9 times negative 12 is negative 108. Hopefully you brought the equal sign straight down. You probably should have done that first. 5 times negative 12 is negative 60. Please double check that you have the negative signs where they belong on both number 19 and number 20's answer. Moving on, last three problems, 23, 24, and then 25. Find the equal sign, bring it straight down. You must use the distributive property once again because we have an addition problem and it is being divided by a number. So 24w divided by 4 would give you 6w. And then 40 divided by 4 would give you 10. Right-hand side of the equal sign, 28 divided by 4 gives you 7. Number 24, 8u divided by 9 is 8/9 u. 54 divided by 9 is 6. Please do not write the 8/9 in its repeating decimal form. I mean, technically you could, but get used to the idea that 8 divided by 9 is 8/9. The equal sign should have been brought straight down. 18 divided by 9 is 2. Last problem, number 25. Did you make the subtraction in between the 8c and the 36 become adding the opposite? Let's see how you did. 8c divided by 12 would be 8/12 c, but the 8 and the 12 can reduce by a common factor of 2, or better yet, 4. That's the greatest common factor. 8 divided by 4 is 2. 12 divided by 4 is 3. And this would give you 2/3 c. Please do not lose the variable, the c. Negative 36 divided by 12 must also happen. Distributive property gives you negative 3. Did you bring the equal sign straight down? I hope you did. 11 divided by 12, do not punch that into a calculator. That would give you 11/12. And that concludes the second page of the guided notes called Working with Equations Like Their Balances. Thank you for watching. We will see you next time.